Good evening, dear students. So, today I am going to talk on some of the terminologies related to electricity. So, we know that all the materials are made up of one or more elements. An element is a substance which is composed entirely of atoms of same kind. An atom consists of three important particles. One is proton, then electron, and then neutron. Protons are positively charged particle. Electrons are negatively charged particle. Neutrons are electrically neutral. Electrons move around the nucleus in the orbit. The magnitude of electron as well as proton is same, which is of 1.6 into 10 to the power of minus 19 coulombs. If this magnitude is negative, then it is a electron, and if this is positive, it is a proton. And neutron doesn't have any charge, and it is electrically neutral. Coulomb is a unit expressed for a charge. So unit of charge is coulomb. So when we understand what is the charge, okay, so let us define an important parameter, electric current. Electric current is nothing but rate of flow of positive charges. Or mathematically I can write it as I is equal to dq by dt. If this particular current is flowing in one single direction, then we call it as unidirectional current. Suppose if we have time on x axis and the current on y axis, if it remains constant with a magnitude, then such a current we call it as unidirectional current. Similarly, if we have a current which keeps on changing with the time, if this is time and this is current, if its magnitude keeps on changing with respect to time, we call such a current as pulsating current. And unit of current is amperes. So now we are going to define another important concept of current, that is direct current and alternating current. So if the magnitude of current remains constant for a given amount of time. We call such a current as DC current. Okay, magnitude is constant. It is similar to unidirectional current. Next, when we take alternating current, with respect to time, the current keeps on reversing its direction. Okay, with reference to the time, the current keeps on reversing its direction. Okay, see, if you see for the time period from 0 to pi, it is in the positive peak, and from pi to 2 pi, it is in the negative peak. So the magnitude of it keeps on reversing as the time increases. Okay, such a current is called alternating current. So now we understood what is the direct current, what is alternating current, what is unidirectional current, and what is pulsating current. Now with reference to current, okay, we will define another parameter called as current density. So what do you mean by current density? It is nothing but current per area. Okay, so current is expressed in amperes and area is usually expressed in meter square. So the unit for current density is ampere per meter square. Next important terminology is voltage or potential. So absolute potential of a point is defined as the amount of work done in bringing a unit positive charge from infinity to that point. Okay, if I'm bringing unit positive charge from this point towards the point where I need to find the potential, I call it as absolute potential. Next, what is potential difference or the voltage? Is nothing but the voltage between the points, say for example A and B. Okay, so the potential difference or the voltage is the voltage between the 2 points A and B. So therefore, energy required to move a charge of q coulombs from point A to point B is usually called as potential difference. So the work I am doing it for moving this particular charge from point A towards point B, I call it as potential difference. So that is why potential difference V is expressed as work done by charge. So work done or the energy we usually express in joules and the charge is expressed in coulomb and the voltage is expressed in volts. Okay. Next we have important passive element as resistance. So resistance is the opposition caused for the flow of current in any material. And resistance of any material depends on length of the conductor or a material divided by area of the material. So when I remove this proportionality constant, I get rho L by A, where rho is the resistivity or the specific resistance. L is the length of the conductor and area of cross section is denoted by A. And resistance is expressed in a unit called as ohms, or symbolically it can be represented as ohm. Next we have an important terminology called energy. So work has to be done in transferring any charge through an element. Okay, so this external force that is driving the current through the element is usually called as energy. So if a unit of energy is considered in this way, okay, if this is an element and this is positive and negative, so if the current is moving from positive terminal and leaving the negative terminal, then element is absorbing energy. Similarly, if the current is entering the negative terminal and leaving the positive terminal, then we say that element is delivering energy. So having known what is the energy, let us understand what is power. So power is rate of doing work. Power is usually expressed as V into I. Unit of power is watts. So horsepower is also unit of power. Okay, horsepower is also unit of power. 1 horsepower is equal to 746 watts. So usually if we consider the unit of energy at home, okay, unit of energy in home or any commercial or industrial purpose, we usually don't call it as just watts. Okay, we usually call it as kilowatt hour. So any in homes we usually tell that when our electricity bill comes, okay, we usually tell, okay, some units have been consumed, right? We have got 30 units or 20 units or 100 units like that. Okay, so that one unit is nothing but it represents 1 kilowatt hour. The unit represents kilowatt hour in case of electrical engineering. Right? So when you want to derive an expression for energy in terms of work done, okay, so usually we have work is equal to voltage into charge. Okay, that is V into Q, which is nothing but V into what is Q in terms of current and time? It is I into T. So we get VI into T. So what is V into I? It is nothing but P. So power into time gives us what is the energy. So when we consider 1 kilocalories, it is nothing but 4.2 kilojoules. Okay. So these are the some of the important terminologies. We will continue in the next class. Thank you.